Oh, I'm okay. I'm okay. Hello, and welcome to a calculus tutorial by Physics Man Education. I'm Physics Man, and today we're going to be doing an example where we use the quadratic formula to solve or find the roots of a few quadratic functions. So, in order to do this, we first need to know the quadratic formula, which we derived in a previous tutorial. It looks kind of like this. X is going to equal to negative of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Of course, this is the solution of a quadratic function where y is equal to 0, so this is the solution to the equation 0 is equal to ax squared plus bx plus c. So, in order to use the quadratic formula, in order to find the roots of a quadratic function, what we have to do is we have to isolate or find the coefficients a, b, and c and plug them in systematically to this formula. So, for a, this should be not too hard. We should be able to just read this off. A will equal to negative 2, b is equal to 2, and c is equal to 1. So, when we go to use this quadratic formula, we're going to write that x is going to equal to the minus of b, so minus b, plus or minus the square root of b squared, so 2 squared, minus 4 times a times c, and that whole thing is square rooted, and then we divide by 2 times a, so 2 times negative 2. Now, we could just at this point plug this into a calculator. Many calculators are advanced enough to do it. We're going to simplify it a little bit in our heads for this particular tutorial. So, we'll say x is equal to negative 2 plus or minus the square root of 2 squared is 4. We're going to have minus times a minus is going to be positive. 4 times 2 is 8 times 1 is still 8. And of course 2 times minus 2 is going to be negative 4. We can simplify this one more step quite easily. We can say that x is equal to negative 2 plus or minus the square root of, well, 4 plus 8 is 12. And it's still all over negative 4. At this point, I don't want to simplify too much further because I can't do the square root of 12 in my head. Again, you could do that in a calculator, but we should notice that because of this plus or minus sign, we have two solutions here. The first solution will be x1 is equal to negative 2 plus square root of 12, and this is all divided by negative 4. And our second solution we'll call x2 is equal to negative 2 plus square root of 12, again all divided by negative 4. And I've made a mistake. I've used the plus sign twice, but I should be using the negative sign here. And there we go. Those are the two roots of this particular quadratic function. Root number 1 here, and root number 2 here. Now you may recall that when we were discussing the possible different types of solutions you may get with a quadratic function, we mentioned that you might in general get two solutions, and when that happens that means that the quadratic function crosses the x-axis twice. Let's do the second one. Well, if you've seen 1.5 million quadratic functions, you might be able to extract the coefficients a, b, and c directly from this. But you might get a little bit confused about what c should really be, because here's where you normally see c, and here it is on the other side of the equal sign. So we're going to actually write the extra step, and we're going to rewrite this function to make it a little bit more explicit. We'll do that by moving the 2 to the other side. So we'll have 2x squared minus 4x. When you move negative 2 over, it's got to become positive 2, and there you go. Now it looks exactly the way that you remember it should look. So we can write right away, a is equal to 2, b is equal to negative 4, and c is equal to 2. Now, we're going to do exactly the same thing we did with example A. We're going to take these coefficients and plug them into our quadratic formula. So, we write x is going to equal to the minus of b. So, minus of minus 4 is just 4, plus or minus square root of minus 4 squared minus 4 times a times c. We'll finish closing the square root, and the whole thing has to be divided by 2 times a. Great! We can simplify this a little bit. We'll have 4 plus or minus the square root of negative 4 squared is 16 minus 2 times 2 is 4 times 4 is 16. And the whole thing's divided by 4. This 16 minus 16 will cancel out the 0. The square root of 0 is 0. So you're going to have 4 plus or minus 0, but both solutions are the same because plus 0 is the same as minus 0. They'll both give you 4. So we can write x is equal to 4 over 4, or we realize that we have a single root. X is equal to 1. What that means is that our quadratic function touches but does not cross the x-axis. In other words, the vertex of our function, of our parabola, will be on this x-axis and it will touch the x-axis at this particular point. Let's do part C. As you can see, part C has all the same components as our quadratic function, but we've jumbled up the order a little bit. In fact, we've taken our a coefficient and put it over here. We can rewrite it in the same format though. I mean, all we do is change the order of the terms. It's not really necessary to do this as a step unless you're not very well practiced at isolating these coefficients. The reason why I'm rewriting them is to make it easier to just read the coefficients off term by term. Sometimes you might have something where you'll have like a plus 6x here. And in that case, you'll have to group the like terms. You'll have to put 5x plus 6x together to give you 11x. We're not going to do that in this example. We'll do that in a future tutorial. We're dealing with this, so a is equal to negative 5, b is equal to 5, and c is equal to negative 3. Once again, we take these coefficients and we put them into our quadratic formula. So we can write that x will be equal to minus b plus or minus the square root of b squared minus 4 times a times c. And the whole thing has to be divided by 2 times a. As written there, 2 times negative 5. We can simplify the radical again. So, we'll have x is equal to negative 5 plus or minus square root of 5 squared is 25. Minus times a minus will give us a positive, times a minus again will give us a negative. 4 times 5 is 20, times 3 is 60. And 2 times minus 5 is negative 10. 25 minus 60, so we'll have x is equal to minus 5 plus or minus. 25 minus 60 is negative 35. All over negative 10. At this point, if you tried to punch that into your calculator would go, uh-oh, I don't know what the square root of a negative number is. You may remember our tutorial on complex numbers, so we're going to cheat a little bit. First of all, you could actually stop here on a test and say, well, this is not a real number because there are no real solutions to the square root of a negative number. And if this isn't a real number, that means that there's no real roots or no x-intercepts of this quadratic function. What that means is that this quadratic function never even touches the x-axis. So we'll forge ahead a little bit anyways, just because complex numbers turn out to be really important in a number of applications, especially when it comes to physics, advanced physics. So we'll forge ahead a little bit anyways, but on a test you could say there are no real roots at this point. I inserted the word real there just to be pedantically accurate. But we'll forge ahead anyways. We can separate this into the negative and the positive part. So we'll have x is equal to -5 plus or minus square root of -1 times square root of 35. And this is all over -10. The square root of -1 is defined as the constant I. So x is equal to -5 plus or minus I root 35 all over -10. And that's about as far as we can go. Because of this imaginary number here, this I, we actually cannot combine both these terms. Something we could do if we wanted was separate them over different fractions, but we can't really combine them. Notice that there are two solutions still. Whenever you have a complex solution to the quadratic formula, you will always have two solutions. It's just that they're not real solutions. And I'll reiterate that language one more time just to make sure that you remember it. There are no real solutions, therefore there are no real roots, which means that you can say without a doubt that this quadratic function never crosses the x-axis. And there you have it. That's the complete tutorial. It was produced by Physics Man Education. I'm Physics Man. I'll see you in the future.